So okay, now let's go to some third common integration. The third one we have seen when previously we have seen when we integrated cos of x, we get sine of x. So now guess, when we integrate sine of x dx, what we get? We get negative cos of x plus c. It's funny, like before when we were differentiating cos of x, we are getting negative sine of x. So now when we integrate sine of x, we get negative cos of x. So that negative shifted, like it's just moved. So this is another one. But there is some also awkward integration, like when you have natural logarithm of ex dx, this one doesn't change. It becomes just the same as it is. And also when you have these exponents, for example, a for x, this is also some weird, you need to memorize it a bit. So it's a of x over ln of a plus c. This is also very common. Let's divide this one so that we may not spend much volume. So also you can see if you have this exponent of, again, is natural logarithm to k power x. When you integrate it, so what you get is this k becomes 1 over k. Then here the power becomes as usual. It's like it doesn't change, like that one. And also there are also some more weird integration, but you need to know them. Like when you integrate sec of x dx, you get natural log, but inside of it there is sec of x plus tan of x plus c. These are some very weird, but we'll see them when we reach to those like trig integration. So these are some common integration which we will deal with. So we need to know them very well, and we need to pass through them very well. But you need to understand, when you integrate sine of x, you get negative cos of x. When you integrate natural logarithm of e of x, as we've seen here, so always like that. So here we do nothing but just summing numbers to the infinity, where the numbers we can't see them naturally. So let's see some more examples, because we didn't solve any examples. So let's see more examples, like numbers, how we see numbers. Example number 1, maybe let's integrate x square dx. How is x square dx? So let's see the solution. Very simple one. You can try more. Here, x squared dx. Let's see this. How does it look? It looks like x power n dx. And we said x power n dx, we do nothing but just x power n plus 1 over n plus 1. Since it's unbounded, it's indefinite, we add c. So here we do nothing, just the same, x squared dx. So what we do is x squared, we take x squared plus 1 over 2 plus 1 plus c, which becomes x cubed over 3 plus c. This is the answer. And also let's go to look for another example. For example, we have e power 2x dx. What we do is this. We have seen this one. This one could look like ex dx, which is normally we said there is ax plus c, but here there is 2. So what is this? So this one is like ekx dx. What we said about this one, we take this k here, 1 over k, and then we take this as it is kx plus c. So it's the same. So here, therefore, we go the same way. So e2x dx, what we go here, our k is 2, so now we get 1 over 2 e, this we take as it is, plus c. So now we're done. I think from this one you can do more numbers. I hope I will give some exercise so you will do more numbers. So again, how well can we go again here? For example, also you given x dx. Can you guess how it is? Here, no worry, this is, since it's x power something, so we use the same principle like power rule. By power rule, xn plus 1 over n plus 1, since it's indefinite c. So here, what is this? X means x power 1 dx. So what you do here is x power 1 plus 1 over 1 plus 1 plus c, nothing else than x squared over 2 plus c, nothing else. So Let's go. Let's change our pen. So again, what number can we see here? Again, like mesela, you given like 0 dx. 0 dx. Integrate 0 dx. How is it? Just imagine. In let's recall. Let's recall from the derivatives. In derivatives, we said what? In derivative, we said if you take d dx of c, like a number is constant, for example 5 or something, you get what? You get 0. Am I wrong? I think it's right. So now we want to turn back from this number to this one. So that's the process, is going from 0 to c. This is what we call integrate. So what here is like when you integrate 0 dx, you get nothing, just c, which is what? Which is constant. So easy like that. So when you understand the concept, it becomes much easier. Also, let's see, like when you integrate k dx, when you integrate k dx, this is like a very special one too. When you integrate k dx, what you do here is like you just bring here like you bring it, becomes kx plus c. Where does it come from? Let's remember this one. In differentiation, I mean, when you take d dx, okay, d dx of what? D dx of, maybe you have kx. What you get here? It becomes like this x, you take 1 minus 1, which is 0. So here becomes k. If from derivation it becomes k, so when you integrate this constant k, eh, integration, this is where you get this kx. That's why I said when I integrate kx dx, what I mean, sorry, when I integrate, this is just when I integrate this k dx, what I get is kx plus c. This is the meaning of this one. So more numbers, we can do still more numbers on this one. Let's see, can do more numbers on this one too, like what more numbers we can do? For example, like let's now be given x 100, the x, integrate this one, maybe from 1 to 2. Now let's start to do definite integral. What is this? I think this is nothing, just like the normal one. Let's recall power rule. Power rule, it says like x power n dx. Now we have integral, maybe put a, b, nothing else than this. So we put x n plus 1 over n plus 1 as we have do. But since it's definite, we said we don't put a constancy, we put our limits a, b. So nothing more. So for here, like we given 1 to 2 of x power 100 dx. What do you think about this one? It's like x, this 100 add 1, and again 100 add 1, put your limits from 1 to 2. You think it's something complicated? No, it's just x power 101 over 101. You put your limits from 1 to 2, and we have studied about these limits. Let's recall about the limits when you're given these limits or boundaries, like when you're given a, b, f of x dx, we are saying there it's capital F of x, but we put our limits a, b. What does it mean? It means you put your upper limit b minus upper limit of a. Let's recall it from the back, because we already did about this one too. So you can recall. So here what we do with our function, let's go back to our function now. It's x 101 over 101, limits is 1, 2. So what you do, instead of x, put your 2, so it's 2 power 101 over what? Over 101 minus, now instead of x put 1, which is 1 power 101 over what? 101. So like this one, there is no need to finish this function, but I just wanted to show you like this is how it looks like. So we may not finish it till the end, something like that. So let me put the other thing. So the other common function here is like this